All right, guys, we're going to go over what seems scary, but it's super easy. It's called equivalent expressions. We're going to first start off with the word equivalent, okay? So equivalent just means equal to. It's just a fancy word. If you look at the root word in there, you've got equal. So we could look at that that root word in there. We see it. So all that means is equal to. So we're looking for expressions that are equal to. Now, if we talk about expressions, those are anything that has the variables and the constants. The only thing an expression does not have is an equal sign. Okay? So the biggest thing we're going to go over first off is the distributive property, because that's a big part of coming up with equivalent expressions. So the distributive property just means, again, going back to those root words, I'm going to distribute something. So let's start off with an example like 5 parentheses 4x plus 7. Okay, so what I'm going to distribute is the 5. It's on the outside of the parentheses, so that means that it goes to the 4 and it goes to the 7. I like to draw these little lines to show that it's going to be distributed. It also, especially because later on when you get to further ones, there might be 3 terms or 4 terms, and so I don't accidentally leave one out. So now when I distribute, that means multiply. So I'm going to do 5 times 4 is 20. X stays with it. 5 times 7 is 35, and there is no x. Now, just in your previous unit, you knew about combining like terms. I looked to see if there's anything to combine. X's and constants are different, so therefore that is my final answer. Now, we're going to do some examples. We're going to start off with one we just did. We're going to do 5 times 2x, so that's going to give me 10 x's. And 5 times 4 is going to give me 20. I can't combine the x's and the 20, so therefore that's my final answer. Now, you're going to see some tricky ones like this. Something that you've also learned before was to always take the sign in front, and if there's no coefficient, to add a 1. Technically, outside of here, there's a negative sign, not a minus. We're going to call this a negative. There's no number, but we know there's at least got to be a 1, so we're going to put a negative 1 there. And we are going to distribute that negative 1 to both of these. So we're going to do negative 1 negative 1 times 7 is negative 7. And negative 1 times positive 3y is negative 3y. So I'm left with negative 7 minus 3y. Now, something you'll notice whenever dealing with expressions is we try to put the variable first. So I'm going to actually rewrite that as negative 3y minus 7. Cannot combine those, so I'm done. All right, now we're going to do this one. We're going to do negative 2 times 5 and negative 2 times 4. The negative 2 does not go to the 3 because it is not in the parentheses. So I've got negative 2 times 5 is negative 10x's. Negative 2 times 4 is negative 8. And then I have my plus 3x. Now going back to our previous lesson, when I combine like terms, I can combine my negative 10x and my plus 3x to get negative 7x's. And then I have that negative 8 constant. And that's my final answer. Now, a little bit of a tricky one. Sometimes you're going to see this, and it's got some exponents in it, and we can do this. It's not that too difficult. So I'm going to distribute this to 3 terms. That's what I talked about previously. Sometimes I have 3 terms, so that's why I like to draw the arrows. So I'm going to first start off with coefficient times coefficient. So 2 times 2 is going to give me 4. Now, I've got x times x squared. This is technically x to the first power. So I'm going to add those exponents to get x to the third power. Now I'm going to do the next one. 2 times 4 is going to give me 8. And then x to the first and x to the first again. I add those up to get x to the second. All right, next one. 2 times 1 is going to give me 2. And then x to the first, and I don't have an x, so I'm just going to have x to the first. Now, even though these seem like terms with x to the third and x to the second and x to the first, they are not. They are all their own terms. So I cannot combine anything, and I leave it just like that.